a signal like this. And even the audience can also participate. If you see one of the interpreters doing this, yeah, you can join in, and that will let the speaker know to take a breath and pause. And finally, the system is good here, but if we can't hear you for some reason, we have this signal to raise the voice. It's a huge pleasure to be here. Thank you so much to the organizers and to all of you for coming out, and that's it.
Thank you so much. Give me a minute to get back to your spot. So, welcome. My name is Cynthia Babbage, and I'm director of the Del Amo Action Committee, and I'm also the coordinator for the Los Angeles Environmental Justice Network. So it's the Los Angeles Environmental Justice Network that's sponsoring these series of stormwater workshops. The LAEJ network is been meeting monthly for about 15 years now, and it's formed of environmental justice groups and then environmental justice enforcement agencies and other agency partners. We meet the second Tuesday of the month. If any of you are interested, one of the sheets that you'll see, your pre-survey, there's some space on the bottom if you just want to note your interest, then I can always send you the link. Right now they're virtual. And the Del Amo Action Committee, my organization, is the physical sponsor for the LAEJ network. And so I just want to welcome you wholeheartedly. Some of you I've known for a long time, some of you not so long, and some of you are going to be brand new friends. So welcome, welcome. Make sure that you eat all of the food that you see in front of you today. It's really important. And if you need anything, you can come to myself, to Caroline, or to Sarah, or any of the folks that you see in the blue shirt, because we are ready to make things happen and get things done. So thank you, and I'm going to pass it on to my colleagues, Caroline, and who will then pass it on to Sarah.
Good morning, everyone. Happy Earth Day. Glad you're here. I want to thank you all for coming. I'm trying to get out of the light. I want to thank you all for coming today here to the Water Replenishment District Albert Robles Center. We have an action-packed day. Well, not action. We have an interesting day for you all. An educational but fun day. So I'm really glad to see all of you. Thank you, WRD, for letting us use your facilities. Jen is in the back from WRD. We have Brian here. Thank you very much for sharing your facility with us. And definitely after today, please come back and bother them with your water questions, so this isn't it. And this is the first of 4 workshops that we're going to be hosting about stormwater, water conservation, and how you can be active in your community. Our next workshop is happening in May, and that's going to be online, and we're going to be talking about environmental justice and water, so definitely we want to hope you all can make it there. And also in your packet, there's a pre-workshop survey. It's a green form. If you could please fill that out. And we'll be around with pens if you don't have any. And once again, thank you very much for coming. I'm going to pass it to Sarah Delgado. Thank you.
Hello, everyone. I just want to share the biographies of our presenters today. So our first presenter is going to be Brian Partington. Brian Partington manages the Hydrogeology Department at the Water Replenishment District. He is responsible for providing technical analysis, review, and oversight for various projects related to artificial recharge, seawater intrusion, groundwater quality, conjunctive use, computer modeling, recycled water, and groundwater production in one of the most heavily utilized groundwater basins in California. Brian has over 25 years of experience in groundwater management and received a Bachelor's of Science degree in geology from the California State University, Fullerton. He is also a California professional geologist and certified hydrogeologist. Our next presenter will be Karina Sandik. Karina Sandik is an Associate Resource Specialist for the Metropolitan Water District of Southern California. She currently assists in managing the Metropolitan's Regional Rebate Program and Inspections Program. Prior to joining Metropolitan, Karina worked for the City of Santa Monica's Water Conservation Unit and the City of San Diego's Environmental Services Department. She has almost 10 years of experience in public service and is passionate about designing and administering water efficiency programs and policies that protect our oceans and natural resources. Thank you. Please take a look at your agenda for today. We're going to have our speaker Brian come on first, and then we're going to have a question and discussion time, after which we will have a short break. Then we will have Karina come on, another question and discussion time, and then we're going to have our lunch. Lunch is going to be catered by Toluco's Tacos in Montebello. If you have any questions, please feel free to direct them to Cynthia, Caroline, or I. Thank you all for coming.
Morning, everybody. I feel like I'm in class. I have half students, and then the rest of us going back to what we probably learned when we were a bit younger. I know myself included. The other button. There we go. Can everybody hear me okay? All right, perfect. Thank you. Okay, so there's a few things I'm going to cover today. The first is I want to give you a little bit of an introduction into the Water Replenishment District and what we're responsible for here in the basin. And then I'm going to walk through the water cycle, the United States Geological Survey, which is essentially the research wing of the federal government. Just think of a bunch of really geeky people that like to work with data a lot. They recently updated the water cycle to provide a lot more information, and when I get to those slides, I provided a lot of words in there, and that was mainly just so that you can take the slides home for you. If you want more information, then you can look on that. But I'm going to really just introduce you to that, but I'm going to talk at a very high level on that. And if you have questions, just ask me, either during the presentation or at the end. That's fine. And then what I thought would be interesting is to show you how important water is for us here locally. So when water does fall to the ground, how do we use that? And how do we use that as beneficial recharge through the groundwater basin? So first, an introduction to the Water Replenishment District. So we are a groundwater management agency that's responsible for two groundwater basins, the Central Basin and the West Coast Basin. And so right up here is right about where we're at, and we're at our ARC facility, and the water that's produced at this facility eventually goes into a pipe, and then it's spread for recharge in those basins right there. And that's important because I'll come back to that later after we get through the water cycle. So it's about 420 square miles. We represent 43 cities, and we've got a population of about 4 million people. And so in the state of California, that's about 10% of the population. So you can imagine, we use a lot of water, right? It's about 550,000 acre feet per year. And you're thinking, acre feet, what is that? Now, a good visual for that is just imagine 1 foot of water over the top of a football field or like a soccer pitch, right? So that's 1 acre foot. And so 1 acre foot is generally about 2 families of 4 for each. Okay, so that's bathing, showering, eating, drinking, and all that. So we're fortunate here that we've got some really productive aquifers. And so we can get about 50% of our water here locally. The rest of that is imported water. We get that typically from Northern California through the State Water Project and Metropolitan Water Districts here, and they'll probably talk a little bit about that in their presentation as well. But really, our main focus is to replenish the groundwater because we're in a desert, right? It doesn't rain a whole lot, and so there's more pumping than what Mother Nature can keep up with. And so we have to make up that difference, and that's why we're here. So this is our mission statement. I'm not going to read through it. I like to point out that one of our key goals is to preserve high quality groundwater, and that's really what a lot of my department does in working with the different regulatory agencies and working with groups like the Delaware Action Committee. So going back about 100 years ago, before we had a very large population, we used to have a good portion of the basin that had what's called artesian wells, and this is like the early 1900s. And so when you drilled a well into the ground, and you got to the aquifer, that aquifer was under pressure, so much so that once you poke through it, water would come to the surface, and that's called an artesian well. And so you can see a child here sitting next to a well that's being drilled, and that water is just naturally flowing out of the ground, and that's because it's under pressure. And so, you know, cities like Artesia, they were named Artesia because of the artesian conditions. And so that has changed over the years as technology got better, we were able to remove more water from the subsurface, and the population started to increase in Los Angeles, right? And so the water level, so this is just measuring the water level underneath the ground in a well, and you can see very clearly it's just going down, right? So that's a bad thing for the basin. That leads to wells running dry, so you're not able to get local water. It also allows the ocean, for example, to start moving inland, and we call that seawater intrusion. And so a lot of bad things happen when your water table drops like that. And so at the time, they were put it to the vote of the people to address these declining water levels. So they needed a management solution. And there were a few things that they put in place. The easy one that seemed to make sense is, hey, you're pumping too much, right? So they wanted to limit the amount of pumping to 281,835 acre feet. But that's still too much. Mother Nature can't keep up with that number. And so what they needed to do was put an agency like ours in place so that we could purchase water to offset that and balance things out. The other thing that they did is the Los Angeles County Department of Public Works, they installed a series of barriers along the coast where they inject water into the ground, it pushes out the ocean, so it keeps it at bay, and then it replenishes the basin. And so we're able to stop the seawater intrusion. And then lastly, and what ties into the water cycle so nicely, is that we needed to do additional recharge in what we call these spreading grounds, which are literally just outside this facility. So if I were to take like a cake and slice the earth and then serve you a piece, this is what it's going to look like in our basin. So on the right-hand side is from like San Gabriel Valley, kind of moving in to the ocean, right? And so these white vertical sticks, I just call these sticks, these are the water wells. So like when I was saying earlier, if I were to drill down in the early 1900s, as soon as I got down here, that water would flow to the surface. Well, that doesn't happen anymore. It just basically flows from here down and out this way. And so the way that we can replenish the water through the water cycle is we can take that water and capture it, and just think of like a big bathtub, right? Just a soil allows that water to get down into the aquifers, and then it'll migrate down here, and these wells can get that water. And then we can also inject water along the coast, and so that's like this purple water here. So it's pushing out the water from the ocean, and then it also replenishes, so that these wells here can still continue to keep on pumping. So just keep that in mind as I start to walk through the water cycle, and when water lands on the surface, where does it go in the basin? So, and we do this because we still have a lot of groundwater supply wells. All these blue and light blue dots are wells in our basin. And so just for example, in the central basin where you're at right now, there's 123 rights holders. These are people that are allowed to remove water from the basin, 64 active pumpers, and 351 active wells. So that's a lot of wells. So they're pulling all that water out. We got to be able to put that water back in there. So this just kind of gives you a perspective of what the well network looks like in this basin. So based on our management practices, we've been able to recover those water levels, and we've maintained those water levels for the past 60 years. And so that's essentially what our agency is all about, is trying to make sure that this line of data doesn't go below the historical past. And there are periods where it goes down during drought conditions like we're experiencing now. And then there's also periods where water levels come up sharply, like you've seen over the last few months and how much it's rained. So I'll get into that a little bit later too. And then there's a number of other activities that we do as the Water Replenishment District. You know, we replenish the basins, and so these are those big bathtubs that I was talking about. These are spreading facilities. And this is what we love to see, a bunch of water sitting in there just filling up the basin. And we love that because it's free water, right? The water that we produced at this facility, it's highly advanced treated water. It's super clean. It's very expensive, right? It's a lot more than the free water that we get from the water cycle. We also do a lot of groundwater monitoring. My group have 8 hydrogeologists, and they go out and sample the wells that we put in with the United States Geological Survey over the last 20 years. So we get a lot of water quality data. We also have many cleanup projects where if a well does end up with impacts in the well, we can put wellhead treatment on that. We funded a lot of those projects throughout the basin. This is an example of what you might see later today at our facility. These are membranes that are cleaning up the water at this facility. I don't know if I'll have enough time to show our basin model, but I have a nice little video that I think is kind of neat and everything, and it gives you a good visual of what things look like below your feet. And then we're the regional water master, and so I said that we have these 2 basins. There were legal settlements. There's an adjudication where they set the pumping, and so they're essentially like the counties. They count all the water beans for our basin. So next we'll get into the water cycle. So the United States Geological Survey recently updated their version of the water cycle. And what I think is really neat is they have this link down at the bottom, and it's interactive. So wherever you see in my presentation, like a little blue word, you can click on that word, and then you can find out more information about what, say, evapotranspiration is and everything. I still have to look it up in it's my field, so it's hard for me to remember things. I think I'm getting a little bit older these days. But what I like about it also is that, is that if you click on this, it's also linked to a Spanish version. So you can, in the upper right-hand side, if you click English, it'll stay in English. If you click Spanish, it'll go into Spanish. And so that helps to break down those barriers to being able to communicate. So this is something that you may have seen in the past, right? And I'll just talk very quickly through what the water cycle essentially is showing on this figure. It's basically just like this conveyor belt, right? I always think this kind of circular conveyor belt where over the ocean, you have the sun, which heats up the water. That water then evaporates and moves up and creates clouds. Those clouds will then move over land, and a lot of the times as they're moving up, say like a mountain, they'll condense and then they'll drop precipitation onto the ground. That water then is going to travel along the ground surface. It can do a few things. It can soak into the ground via infiltration, and it can make its way down into groundwater, which I love and everything because I like studying that. It can go down and it's runoff into a river or a tributary into a larger river, and then it can make its way out to the ocean. And then that whole cycle starts over again. And you can see there's a lot of other terms on this. I think of like this year was a really good rain year, and so we know that there's a lot of snow up in the Sierra, right? And so in the Sierra, when snow evaporates, hold on a second here, it's called sublimation. So on the newer version, which is this one, this is the new version of this. You can click on any one of these. So if you wanted to learn about sublimation and what that really means, you can click on that and get a more detailed description. Especially for some of you younger folks that are still in maybe junior high or high school, this is a really good resource and everything if you're having to do some kind of science project and you wanted to learn more about this. And so I'm going to walk through this really quickly. I'm not going to spend a whole lot of time. Again, I provided a lot of material in here, and it was more so that you can just take it back and read it. If you had any questions, you can go to that website and just click on things. The other thing that I like about this is I've been doing science teaching since my kids were, first in kindergarten. I think it was the first one I did. And I think I've done the water cycle probably from kindergarten all the way up to about 8th grade when my kids finally said, yeah, Dad, we don't need to do this anymore. But I liked using these because these were all interactive as well, and they're for early kids, really young kids, on up to some of the older kids, maybe up through the middle school, high school, kind of thing. And they're all interactive, so something for the family. So the water cycle, as I kind of talked about earlier, it basically just describes where water is and how it moves in the earth. And when we think of the water cycle, it's easy to think of the liquid side, right? It's water. It's what I've got inside this bottle right here. But water is also in two other phases. It can be in a solid phase, so think of ice, right, snow. And it can also be in a gaseous phase, so like as it's moving up into the atmosphere to create clouds. And the way the USGS is describing them now is they describe them as pools. So I think of like a distinct, like a pool in your background, but if I think of like a lake or a river or snow up in the mountain, these are different types of pools. And I think the most important thing to remember about water is that 96% of the water is in the ocean, right? And we don't just go out to the ocean and just pick up that water and drink it, right? We have to treat that water. The fresh water is only about 4%. So there's a very small amount of fresh water, and that's why for us as a replenishment agency, the groundwater is so very important for us here locally. The USGS, because they're scientists, they have to put out like fancy terms like flux, right? Well, flux is essentially just something moving from one location to another area, right? So when we talk about the water cycle, we know in the ocean, things circulate, water circulates within the ocean, and it's also circulating in the atmosphere as through transpiration going up to the clouds. Water can move across the surface like I talked about earlier. Snow melts, it goes down into runoff, and then it goes out into stream flow. And then eventually, where I like to spend most of my life is when groundwater goes down into the subsurface as groundwater. We already talked about how the sun drives this entire engine, and it also has to do with gravity, right? Because gravity is going to pull that precipitation down to Earth. The gravity is going to allow it to go down into the streams, and the gravity is going to allow it to go out to the oceans. And so I think the last slide that I was going to touch on for the water cycle was climate change. How many people have recognized that the climate has changed, especially in their own lifetime, right? I think most everybody's recognized that. I think I'm fairly still young, even though I'm in my 50s now, but I can see it, and I deal with it on a daily basis, and I've recognized that we're starting to see more frequent, like intense storms, right? And they're very sporadic. We're going through periods of long droughts where we haven't seen those in the past, to years where we have a massive amount of rainfall, like this year. This is a record year for us. And so it makes it really challenging to kind of predict or plan, because my job is to look out into the future and try and figure out, do I have to buy more water to put in the basin, or can I wait for a really nice year like this where I get a lot of water and it fills up my basin, right? So two other terms that I was going to throw out too, just because I think they're neat and they're talked about a lot in the news and the media, La Nina patterns, so El Nino and La Nina patterns. So La Nina patterns typically means that the jet stream is pushed further north, that's this. And that's how we get a lot of our rainfall, is water coming from out here and it ends up hitting into our coast, because the jet stream goes from this side of the paper or the west coast out to the east coast. So it's drawing all this Pacific Ocean water in our direction. So in La Nina years, that just means that most of California and the Southwest is predictably drier. And it's generally about 70% of our average rainfall. But when I track rainfall every year, I looked at the last 3 or 4 years, they've been some of the lowest on the record. And so again, that climatic conditions keeps on popping up in my head. The other really interesting thing that we've done over the last few years, because we're trying to forecast, trying to understand these atmospheric rivers. This is a term that came up in the last few years where it's trying to describe how our weather patterns typically come off of the Pacific, right over here. And in my presentation, this is animated and it shows it kind of moving around. But if you can imagine a band of very narrow, like this, but hitting the coast like that, that would be called an atmospheric river. I think a river is very narrow, right? And it goes for a long distance. And that's essentially what this is. That it comes in and it kind of slams into our coast and gives us these very intense rainfalls. And so now they've come up with a system to describe that, right? So they use a color system, the white being 0 or no AR, on up to red meaning a very intense AR. And so just to give you an idea, this is a screenshot from their prediction on March 10th to March 17th of this year. And so when I was sitting at home going, okay, cool, I'm going to get a lot of rain. I can shut off all of my sprinklers. Everybody here is getting excited because all of our basins are going to get filled. And this is what ended up happening in our area. We got like a yellow and a green, so that put us in the middle to the upper end. So that was really neat to be able to see that. We never had this predictive tool in the past. And so I thought that was kind of neat and everything, and how things are changing and how climate folks are looking at this and trying to predict what we might see. So I'll walk you through in this last few minutes through an example, like what's happening right here. So how do we manage water? And this is a water conservation example for the San Gabriel River system, which is just outside the door here, and how we beneficially use that water to recharge. And I say MFB is the Montebello forebay, and that's the forebay that we're in right now. So again, my presentation from here on out is going to focus on this right-hand side right here. And it's really just focusing in on these pools that we have right here. And I don't know if I mentioned this earlier, but the reason why this is so important is because all this blue and all these little stippling things, that's all coarse grained material, and that allows water to move easily. So think of like sand at the beach, or like pebbles and cobbles that you might see in a river. Well, that's what all this is. So you imagine if I were to pour a bunch of water on top of that, it's going to percolate down in, and it's going to fill up these basins. And so it's a great thing. It kind of comes up here, and it just happens to show up in this portion of the area. So the concept of a watershed. So when rain falls to the earth, it decides where it's going to go based on a watershed. And so the outline of this watershed, this green area, see this orange line that goes along here, is along like kind of a ridge. So just imagine like a mountain, okay? So if I have one mountain like this, if a raindrop falls on this side, it's going to go that side, right? If rainfall drops on this side of the mountain, it's going to go that side. The peak of that mountain defines what the watershed is. Does that make sense? That's fairly simple, right? So any water that drops as part of the water cycle in here is going to work its way down. It's going to go into all these little tributaries, and eventually it's going to end up into this line right here, which is the San Gabriel River. And you are sitting right about there. I think we're right about there. So